Namaskar, my dear friends. Let us design and simulate inverting amplifier in NI Multisim. So we will see various examples, a circuit with different input voltage and gains, and we will try to see what is the output for inverting amplifier. So as all of you know that inverting amplifier configuration is like this. We have positive terminal and negative terminal of the amplifier. We have an input voltage which has to be amplified, but it will be inverting. So if my input voltage is positive, my output voltage will be negative, right? Similar to that, if my input voltage is negative, the output voltage will be positive. So as all of you know, V output is nothing but minus R2 by R1, which is R2 is this feedback resistor and R1 is this resistor, right? So minus R2 by R1 into V in. So this R2 by R1 is the gain amplitude that is there. Okay. So with this understanding, let us assume like gain is 10. Gain is 10 means what? We can have a various, like example, let us say R2 is equal to 10 kilo ohm and R1 is equal to 1 kilo ohm. It means what will happen? R2 by R1 that is 10 by 1. So gain can be decided 10. So this is the method you can set your gain for your requirement. So let us say what will happen for this case. Input voltage is let us say 10 millivolt or 0.01 volt, that is going to be 10 millivolt. So my output will be what? Minus 10 times this. So that is going to be minus 0.1 volt, that is 100 millivolt. Okay. So I have designed some circuits. Let us say one circuit is this one in NI Multisim. And as you can see, gain is set how much? R2 by R1, that is nothing but your 3 by 1, that is 3. So my gain is 3. So whatever the input voltage is there, the output will be 3 times of that. Okay. So input voltage is 1 volt. It means input voltage is 1 volt. It means my V output will be minus R2 by R1 into V in. That is going to be minus 3 into 1. That is minus 3 volt. Okay. So as you can see, I have put a like probe here, PR1, that is output probe, and this is input probe, that is PR2. So PR2 is 1 volt. You can see here red color PR1, which is the green color, which is 1 volt, 0.5, 1, 1.5. So 1 volt. So this is my input voltage, which is green color, which is 1 volt. The output is expected to be how much? Minus 3 volt. So you can see this is 0, like that it is minus 3 volt. So red color is minus 3 volt, that is your PR1. All right. So let us rerun it and see whether it is happening or not. So I have opened here. All right. So I have opened here this particular circuit. So you can see we have 1 kilo ohm and this is my load resistor. So if you want, I can put the probes. Let me do the same, use the same probes. No, this is my PR2 and this is my PR1. Okay. All right. So if we run it, what is going to happen? This is the graph that is there, which is going to be like my PR1, that is nothing but your input voltage. Sorry, that is output voltage, which is your minus 3 volt, and input voltage, that is 1 volt. Okay. If you want, you can change this voltage. Let us say I make it 0.5. Then what will be the output? The output will be minus 1.5 volt. So let's rerun it and see. This red color is minus 3 volt. Right now it will become minus 1.5 volt. So see, minus 1.5 volt it become. Understood? So hope you have a good understanding how to design this particular circuit. If you want, you can learn how to place the components in my previous videos, like how to place resistor, or voltage probes or voltage power sources, all those things, how to put probe, how to put this particular amplifier. I'll just show it to you quickly. Go to place, component. So in this component window, you will have master database, and from here you can go to analog. In analog, you have lot of op amps here. So you can search for one of the op-amp, let us say LT1419, something like that. If I'm using, you can use that. Okay, 14 1494, right? So LT1494. Okay, so like that you can utilize. That's all. So this is the op-amp that is there. Okay, let's move to the next one. One more example I have taken is this one. So let us say my input voltage is 0.3 and what will be my output? So output is based on the gain. So here gain is set to be 5 by 1, that is 5. So it will become 5 times. So output will be 5 into 0.3. V out will be 5 into 0.3 and that will be negative. So minus 1.5 volt. So can you see the output here? My input is 0.3 volt, which is my green color. Okay, like 0, 0.2, 0.4. So this is green color is 0.3 and this one is minus 1.5 volt. So this is all done. Similar to that, quickly you will see this gain. So this gain is said to be 3. Why? Because R2 by R1 is 3 by 1, that is 3. So my output will be how much? Minus 3 times input voltage. So input voltage is 100 millivolt or 10 volt, right? Sorry, 0.1 volt. This is 100 millivolt. So this is my V out. My V out will be how much? Minus 3 times 100 millivolt. That is minus 300 millivolt. Okay. So you can see green color is input, which is 100 millivolt, and red color is output, that is minus 300 millivolt. Okay. Similar to that, let me give you one more example. Like I am going to take a sinusoidal voltage. So sinusoidal input voltage is 1 volt peak. So 1 volt peak you can see 1 volt up, then 1 volt down, also negative cycle. So green color is your input voltage. Now again the gain is same 3 because 3 by 1, that is 3. So output will be 3 times of this. So what will happen? Uh, Whenever the cycle is positive, that will become negative because it is inverting amplifier. And whenever this is negative, that will become positive, that is inverting amplifier, right? And the value, the amplitude is becoming minus 3 and plus 3. Understood? So this is how inverting amplifier you can design very nicely. Understood? Let me change the source to, let's say, pulse wave. Okay, so pulse signal is there, plus minus 1 like volt. So plus 1 volt positive and minus 1 volt negative. If you want, you can make the changes just like that I have shown you in our previous videos, right? Same gain is said to be 3. So then what is going to happen? The output will be plus minus 3 volt voltage levels, right? So whenever this is plus 1, this will become minus 3, and whenever this is minus 1, this will become plus 3. Okay. So let us quickly see these simulations. So come back to here. I have done, let me take this probe to here so that the output voltage graph doesn't clutter. Okay. All right, so this is the graph that this is the schematic that is there. So we have VCC 5 volt, minus 5 volt. I have given negative as well so that if my output is going to be negative side, it doesn't change. Okay, it doesn't clip off. So if I run it, what is going to happen? You can see, I'll just take it here so that you can see everything together. You can see my PR2, that is your input voltage, which is going to be 0.3 volt, and PR1, that is going to be 0.3 into 5, that is minus 1.5 volt. Okay, so this was this graph. Now let us take another example. I have pulse signal. Okay, so in this pulse signal I am going to put the probe here and the input probe here, and we'll do little bit more analysis in this graph, and we can change the sources, we can do all the other things. Okay, all right. So this is the schematic that is there. What is the gain that is set here? 1 kilo ohm and 3 kilo ohm. So that is going to be minus 3 times. So 1 volt peak to peak, so that 1 volt is there negative, 1 volt is there positive. So what will happen? It will become plus minus 3 volt. So let us run it. Once we run it, you can see the pulse signal. This is my green signal, which is signal which is going to be input voltage, and red signal which is going to be output voltage. Why? Because the legend is shown here, VPR1, that is red. So VPR1 is here, output. Okay. Now I'll change this source. Let's say I'll change this source to go to place, component, and come back to here sources. I'll just take voltage signal source as AC source. Okay. So if I put here AC source, then what is going to happen? I'll just quickly connect this. All right. Now if I run it, what is going to happen? 1 volt peak is there, so it will become sinusoidal source with 1 kilohertz. So let's run it. So 1 kilohertz this, like this. If you want to have less number of pulses, what do you need to do? You come back to this simulate, then analyze and simulate, and this transient you can run for little less second. Like let's say it is running for 10 millisecond, I'll run it for 5 millisecond. Okay. So 5 millisecond only 5 pulses will appear. Okay. So let's run it. So you can see only 5 pulses are there. Now let us say you want to change the voltage levels. So I don't want, like 1 volt peak to peak. I want, like 0 point, let's say 4 volt or 0.4 volt, let us say. So peak will go to 0.4 and it will become 4 3s are 12, that is 1.2. So negative is will be minus 1.2 plus 1.2 because gain is 3 times. So let us see that it happens or not. Yes, it's very nice. Like you can see 0 0.4 it is happening, like less than 0 0.5, and it is going to be 1.2 volt. 1.2 then 1.5 is there negative, right? So this is the way you can make changes. This is a load that I have used here, 10 kilo ohm, which is quite big, like low load. So higher the value, lower the current that is flowing. So if you want to check what is the current that my amplifier is, like giving, you can put a current probe as well. Okay. So you can see, let us say I'm going to put a current probe, which is PR3. So let's run it. So you can see we have PR3, which is going to be almost 0 because it is a voltage, like a rating. So I can go and make this trace width little thicker. So this is the current that is flowing. If you want to see the values, what you can do is you can delete this or you can cut that and go to simulate, analyze, and go to interactive session. Okay. So you can see all the voltage values and current values will be appearing at the nodes. Okay. So here you can see what is the current value, what is the voltage value, and everything. So current will be keep on changing because it is a sinusoidal current. So that is keep on changing, you can see. Okay. So if you have a DC input voltage, what you can do? If you have, let's say we had here DC input voltage, right? Yeah, here a DC input voltage. So the current and voltage will be DC signal. So I will quickly put another, like probes. Let us say voltage probe I will put here, and voltage probe I will put here, and one current probe I will put it here. It is going to be negative side. Okay, just you will see the current is negative. Okay, so let us run it. So you can see the current is fixed now 150 microamperes. Okay, and the voltage is also fixed minus 1.5 volt, and input is 300 millivolt. So 300 into 5, that is 1500 or 1.5 volt. Okay, so 1500 millivolt is 1.5 volt, that is there. So AC signal it is changing, but DC signal you can see it is constant. Okay. So alright guys, hope you have a good understanding of how to design and simulate inverting amplifier in NI Multisim. And this is very interesting and very powerful tool to understand your complete circuit design. And if you need to have, like a proper evaluation of your opamp that you are selecting, you can always select that particular opamp in your component placement and like try to evaluate that particular op-amp for your actual values of resistances that you are going to use. And what is your input signal? I have shown you, like DC voltage, AC voltage, pulse voltage, any kind of voltage that is going to be at the input, you can do that. So if you do have any questions or any understanding that is needed, you can put your questions in the comment box and we shall be able to answer you as soon as possible. Thank you.